running is becoming a very popular sport in the U.S. and many people are doing it recreationally and professionally. But there are people who do have very bad running form, and this causes running injuries. From shin splints to IT band syndrome, all of that. So basically, what our product does is we're kind of checking to see how your strike type is. So do you land on the heel? Do you land on your forefoot? Do you land on your midfoot? And we also check to see what your cadence is like. So how many steps you take per minute. And what these correspond to, so basically, if you're a heel striker, you don't have as much knee flexion as as someone who strikes with their forefoot. And the knee flexion is what cushions the blow every time you take a step. And in terms of cadence, if you're taking a lot of steps per minute, that means you have a shorter stride rate, and that's been known to prevent injuries. So what we have here, we have pressure sensors in each region of the shoe, so heel, midfoot, and forefoot, and they're basically sending the info as we take like a short 30-second jog, putting it onto the computer and outputting the percentage of time you spend in each region. And we also have the cadence, which is measured by the time between each step. And we try to rectify this too in the second part of the run-through. We have a buzzer that sounds if you're spending too much time in the heel position. We want you to, that reminds you to try to run more on your toes or midfoot. And we also have these LED lights on the side, which basically blink in 90 steps per minute or so, which is what the biomechanics around, they recommend this cadence for proper running form.
Right, so
looking at your feet?
Well, I mean, like, you can glance down from time to time. Yeah.
It's one pattern that just goes, so 90 steps per minute.
Right. So I'll put it on while Sunny explains what's going on in the computer.
Yeah, so basically just on the software side, it reads from 3 pressure sensors that are located, as Aditya mentioned, on the back of the foot, the midfoot, and the forefoot. So there's just 3 pressure sensors, and that's also used to determine cadence. And the way that cadence is determined, which is just basically like whether or not you're taking a step, is basically like we determine, I guess for sake of demonstration, I'll just take my shoe. Like for every step you take, like you basically follow this form. So every time you're going off of the front of your foot onto either, depending on what kind of runner you are, the heel of your foot or the mid part of your foot. So basically it determines when a transition is occurring from the front state to any other state, and it counts that as a step, and it just increments a step counter. And then it uses the total percentage of time to determine what percentage of time you're staying there. So we'll just do a short demo. It consists of 2 20-second bits, one which doesn't use the buzzer and one which does use the buzzer.
And I'll be showing you what a heel strike type looks like and a forefoot strike. I've actually had knee problems in the past, so I've made the transition into a forefoot strike, so that's what I'll be starting my demonstration with, and we'll show what bad running form looks like afterwards.
Okay, right? So we'll start now.
So you see, I'm using more of my midfoot and forefoot when I run, and very lightly on the heel. Well, I mean, you can come to the computer when it's done. It's basically printing letters of, so either H, M, F.
And then after 30 seconds, as you see here, it'll output what your heel percentage is, your midfoot percentage, and your front percentage. So as Aditya mentioned, he's transitioned out of heel, like being a heel foot runner. So you see that his front percentage is 50%, and his midfoot percentage is 15.14%, whereas his heel percentage is way down. So yeah, and then in the second part, we basically activate the buzzer to show you whether or not, if you're over the 40% threshold for heel running, that means like you should probably stop doing that and transition out of it. So that occurs too. Yeah.
So.
Yeah, so after that 30-second bit, it'll transition.
Right, so we'll wait a little bit.
No, just like do like.
Yeah, wait.
So this is just to demonstrate the heel part.
So the little bit time is all pressure.
Yeah, it's all pressure.
Okay.
Pressure determined.
So this is me on my heel, and if I make the transition to forefoot, it should
As long as it goes below the 40%.
So that reminded me, oh, maybe I should be running on my forefoot, and the buzzer goes off, so that means I'm running properly now.
Yeah.
So it's real time correcting you how to do it.
Right, it's calculating the percentage of each, yeah.
So maybe a quick explanation of what the electronics is doing after the sensors?
So basically it's being sent through the XP, this is the transmitter, this is the receiver.
So this is doing nothing but taking those
The value,
samples of the three things and
spitting
sending
it out, and this is just a simple like buzzer circuit right here, and we're outputting high if the percentage is above a certain amount.
So this thing's doing some integration to decide this percentages?
Right, so it's, yeah, we're calculating it here, and then
Calculating on the PC.
on the PC, and then it's,
Sending it back.
yeah.
Yeah, every 100 milliseconds it takes a sample of what the pressure is in every time, and at 500 milliseconds it averages that out and outputs into this. So you have like a good idea of what's going on on each of the three regions of the foot. And as you said, it connects the averages of some.
So you could have completely bypassed PC or no? All the calculations are done in PC? On the
Right.
Mac side?
Yeah, they are right now.
Okay.
But you could bypass it theoretically if all of it was just done on this.
Okay,
And
then
then-
you could have done it.
Yeah, we could.
Or on
On the other two.
Right.
Are they,
Okay.
Oh, yeah.
Not on the
sorry.
PC.
The code is running on the.
yeah.
Someone.
I'm sorry, I thought yeah, somebody needs to see.
My bad.
So, how many sensors do you use inside the shoes?
We use 3 sensors for each region, but like, I mean, we would want the whole sole to be like a sensor. So what we plan this to be like in the future, if we were ever to expand on this, is the whole sole being filled with sensors and a map, a force map being displayed here. So that would display maybe your arch. Are you flat-footed? Are you do you have high arch? Do you need orthotics? Are you pronating when you? So is your foot like bouncing around? Cadence will be measured like much more precisely. Maybe we can involve knee flexion in here. There are a lot of things that could be done, and people want this information. Like I know, like when I was injured, I really needed this information to tell me like what I needed to do to get better. And I'm sure like people who go and buy shoes, you know, if they slip this on, it spits out information. You know, they can pick the right shoe. You know, like oh, you need high arch. You have a high arch. You pronate a lot. You need cushion for the heel.
Maybe you don't need to make a shoe, you just need to make a sole. So you
Right,
can place them in doctor's office. Every time people come into his office, you put it in their shoe and let them run for a week.
Yeah.
And collect the data and do
Oh,
it.
definitely.
Because with the whole shoe, it'd be more expensive.
Doesn't Nike or somebody have one that at least counts steps?
Yeah, they have.
So how far of a delta is this from that? So they only have one sensor and you have three, or?
So what they do, I think it's. You're talking about Nike Plus? Or,
Yeah.
Somebody.
Yeah, the one that you velcro to the shoe.
Yeah.
Right. So it's it goes in the shoe.
You need to keep going.
It measures you know distance traveled and like I guess the pace, but it's not doesn't really have to do with your biomechanics. It's just like oh, I want to run a 6-minute pace for like 2 miles, let's say.
But a question might be is that existence proof of how compact it can be, and is that if there any small changes or something like that that would
I think
improve the functionality?
I think they use more like your position and like using GPS. So I don't know if it's like more. This is more.
They don't already have a pressure sensor?
I don't think
No,
so.
they don't have pressure sensor.
So
Only
one
acceleration.
So.
Alright, so we gotta get going, guys.
Alright, guys.
Okay, thank you.